morning. We will be talking about state management, especially like in Flutter, what we've been doing for the better part of the last half year. So yeah.
Yeah, so this whole topic came about because we have rewritten the About You shopping app from React Native to Flutter. So maybe some of you are on a similar journey here. Does anybody have experience in Flutter yet? Or? Okay, quite a few. Does anybody have like shipping, production experience? Like huge apps? Like one guy over there, and yeah, of course, okay. Like some of our team here. Okay, cool. Yeah, so while this is about Flutter, even though the language didn't say so on the conference page, it will be mostly about Dart, but a lot of the patterns are also applicable to your React or similar view state-driven framework that you might use.
Okay, so first we'll in general talk about state-driven UI and what it means. Then we will quickly go like deeper into our implementation and also what we've used before. And then we will have some app scale management, what we've learned in our like quite large app these days. And afterwards, just like Q&A.
Yeah. So the whole talk will be like very technical. There's like a ton of code on the slides, which you are free to use. All the stuff that we show, like the libraries we worked on and like the example code, is online for you to enjoy after the talk. So yeah, that's probably like the main driver here, that we share what we've been doing, and if you want to, you can just join the conversation and yeah, bring your points, and we evolve this code. Okay, yeah. So overall, what is this about? The mic is a little flaky, right? Okay, I'll try to make that better. The basis of everything we're talking about here, which is the same between Flutter and React and whatever new framework have you like Swift UI, is managing state in like view state driven applications. So we have this classic mapping function here from the state on the left side, building the UI on the right side. And then somehow whenever the user does something in the UI, it somehow influences the state to then build like a new UI. There's like various patterns out there, like from React, we know Redux, which we'll dive in to later. And for Flutter, we needed like a similar approach to keep everything in sync. And this is where we came up with our pattern that we'll explore later on. So in our world, like this view state driven application really means that I would say like 95% of the stuff that is on screen is like in some state that we can like work with in a purely like data driven way. And only very few things like current scroll positions and some focus topics are out of the state and just implicitly somewhere in the UI, in the framework, where we don't have like complete control over. But the idea is to get more and more into our control, so at any point in time we can know exactly what will be on screen and what is and isn't allowed at that point for the user. So the most important thing is having like a single source of truth over here, especially with our pattern later. That will become more important. If you're familiar with Redux, you will have that already because you have this one huge store. Then we think like this is the basic for using like a declarative view library like React or Flutter. It didn't came about that way, but like working on the talk, say, okay, this really only makes sense in that context, and we are really happy that we have been working with such libraries for the last few years, so it didn't occur to us that this is actually like a special thing that we are grateful that we have now in our toolkit. And then, yeah, the whole point is cleanly separate your data and the view, and keeping everything in sync at the same time. Now Henri will start out showing a little bit our journey. So we have this React Native and also React on the web background. What we've learned there, a lot of the things worked really well there, and how that helped guide us through the approach we are now taking in Flutter.
Okay, so I will now. So this is basically just like a Redux recap. We both had previously worked on React apps before starting Flutter, and Redux was created in the React ecosystem, but it has since you can find libraries for Vue, Flutter, Swift, UI, and so much more. The main there's three principles around Redux. The one is being that it uses kind of a one-way data flow, which is nice and makes the state more predictable and reproducible than, for example, previous two-way data binding, if you remember them. And the state is read-only and can only be changed through so-called actions. So if you look at the graph here, the UI would dispatch normally an action. The dispatcher then notifies the store about the action. We rebuild the state, and the UI reflects the new change. It seems all very easy in practice. In our applications, it started looking more like this. And that happens when you introduce asynchronous side effects into the store. So it all gets kind of messy. We used a library called Redux Saga, if you're familiar with it. So basically, a so-called Saga is triggered by an action and can access the whole state and dispatch any action. This led to some kind of very spaghetti code doing more than it should do and not really understanding what it might not do. And every Saga was dispatching at the end further actions, which would trigger more Sagas, which would trigger more Sagas. So you would end up in this kind of loop, and it became hard to follow what an action might actually do to the store. Something which also then later on was really hard to develop with is that click to definition, something which you would expect to work, just didn't work. If you click to the definition of an action, you would end up at the definition of the action. That's not the place where our implementation was. What we would do is kind of click through references until we're lucky and found the actual implementation of the action and can see what has actually changed. This was really annoying, especially if the action was triggering multiple Sagas, doing store effects, and much more. So in the end, it really became more pain in the ass to develop store changes. And that's what we've more or less learned from our previous applications. Something to be aware also is that performance was at the end also an issue for us, because your kind of components in React subscribe to the whole store. So whenever you make any change to the store, all of your components at least need to re-render to a certain point to check, hey, do I need to really do some work here? And that's just not efficient, because you can do way better in most cases. So when we started with Flutter, there's a really popular approach, mostly popularized by Google itself, called so-called block. Block stands for business logic component, and the pattern is based on streams, and a very basic, really basic version is actually built into Flutter, the core framework itself. Our inputs are here so-called sinks. You would put data into it, and then this block would listen to this kind of also stream in a way, and whenever you put something into it, it would push, for example, a new state to the output stream. The widget, in Flutter it's called widget, similar to React's components, would then listen to the output stream and rebuild whenever needed, so when a new data comes available. again, like in theory, it looks really easy. With one input, one output, seems manageable. That would be more like how we would actually have it in production. So it all becomes kind of messy. And our biggest issue with that was that the streams, everyone needs to be a stream expert. If you ever looked into like RxStart, RxJS, all of these reactive stream frameworks, they have about like 100 different methods doing similar stuff, but then behaving differently in edge cases. So someone might want to use a different RP for something, and this could lead to, first of all, very inconsistent code in terms of what's actually being used, and also just bugs because someone might not know how a certain method behaves in a very edge case, and so on. Again, as you see in our example, we have multiple sinks now, we have multiple outputs. We ended up having quite big issues like synchronizing them inside the block itself and also in the widget outside. If someone decides that like a new input, they would need to make sure every output is adjusted and vice versa. So the code become relatively large and disconnected from some parts. So we decided to scrap that and build our own state management and kind of really take good points from both sides and combine them into our own state management library. And that's what Timm going to tell you about.
Yeah, okay. So what we've really valued from the Redux side was having like this atomic state, everything updates at the same time. As we saw before, if you have multiple streams concerning the same data, they might not be always in sync, which is probably fine in the UI if you skip like a frame with the wrong data, but if you want to combine them and do something with the output, that gets harder and harder to manage. So ideally what we wanted is just to have like a simple class that has like a set of methods that we can just click through. They have like a proper name. They are like directly connected to what side effects they will have, and everything is like in one place for this one update operation. And on the output side, they should have this one atomic state. And without really thinking about it, just knowing it from Redux, we opted to make this state fully immutable, and any update to any part of the state will then, of course, cause like the bigger state object to be updated. And that fits really well with some of the standard Flutter framework classes that are available, mostly value notifier and value listenable builder. So you can just put any observable value in there and the UI will update whenever that changes. Yeah, so this is our goal. One thing which was alluded earlier is that we have like a lot of async operations, and you wouldn't know like when they run. In the previous version with Sagas, it could be that async operations get cancelled, and then they have like done parts of their work, like maybe 50%, and then we had some special code. Okay, let's pick up the state and move on from there, and that was like messy to handle for cases which, like in real app usage, really don't happen that often. That something needs to get cancelled midway. So this is our like ideal interface that we want to build. And now let's look at an example how it will work, and then later on we dive into the code and continue on the Flutter side now that we have explored our background. So just like a super simple class, we make this instance of such blocks available to the UI, and then by some action, usually like a tab or some gesture, a method gets triggered there. This method in turn then schedules something which we call updater. So updater is just like an asynchronous function which is guaranteed to run until completion without any interruption. So while this is running, nobody else will update the state. So it will start out with the initial state, like state 0 over there, and then it can emit as many new states as it wants without having to deal with like conflicts of other operations updating anything in parallel there. Yeah, in this case, this updater actually does it. So it emits a new state, and that in turn updates the overall state of the block, which then in turn would update the UI. Now, in a different example, it might be that we call method 2 here, which schedules like an updater, and like super immediately afterwards also method 3, which schedules like another updater. Since they are both async in this example, they might not have started running at all yet, but you can already see that they're like queued in sequence, and we would first run updater 2, which in the simple example doesn't emit any new states, but it could also emit like 10 states, and then after that has completed whatever it did, updater 3 runs, emits a state, updating the block output, and then emits another state all by itself, and then updating the final output. So this is like the theory how this whole thing behaves. We think that is like a radical simplification from the previous spread across multiple files approach with actions and sagas and reducers. Here we have everything in one place. So if we now look at the code, you can see whenever we create such a block, it has to extend from the state queue, which is our class that we talked about. And then we already see, like if somebody is familiar with like the stream-based block pattern, like the first few differences. So always here in the second line, we start every block having this like initial state. So we can use whatever is appropriate for our domain. In this case of a locked in block, we start like locked out. But in some of the other approaches, you would have to deal with, okay, I have an empty initial state, I need to provide my own fallback state, and we always found that to be quite cumbersome. Sometimes you find yourself doing that in multiple places in the UI, so we said it's cool to have like one single state and have that always available whenever you have an instance of this. Then we have two methods on this block. One is login, one is logout, and in both you see that they start with this invocation of this run helper. So this run helper is the thing that schedules this asynchronous job that can't get interrupted. So this is always what you have to do here, and only inside this run helper can you actually, by yielding, as you see in line 5, can you actually update the state. So the login method checks that you're either logged out or you're in some error state, that a new login would make sense. If that is not the case, it just can't do anything useful, and you would usually like assert that this is not happening or log it to your thing, because it represents a failure in the UI. The UI shouldn't even be displayed if that operation is not valid at this point in time. So in this case, we start out with this like in progress state. So this could show like a loading spinner on your UI, whatever makes sense, and then the actual work can begin now that your UI is updated. So instead of a real API call, we just wait here for a second and then check that the password is like not too short. And then we yield like the final states, either you're logged in or we show you like an error message. Logged out behaves similarly. It checks that you're actually logged in. Otherwise, again, it would be like an invalid operation, which you should prevent. And then we log out. One thing to note here is that at the top, you see that the generic type of this whole block is defined as login state, but then further down, we are never using that login state directly, but always emitting like more specialized instances. This is something we grew accustomed to from TypeScript. So here we use union types to always have like the perfect state shape for all of our states, which in turn also basically forces you to write the correct UI, because you only have data that is actually there, and you don't have to deal with like empty lists or nulls or whatever, which we might usually have in other classes. Yeah, maybe just a quick deep dive if like not everybody is familiar with either the TypeScript side or the Dart side where we ported it to, how we approached that. So this is actually how the state would look like for the previously shown block. So we have the login state, and that gets implemented, which doesn't mean much, but the Dart compiler can then narrow it down in like type checks, otherwise that wouldn't work, into very specific states. So your logged out state or in progress, they don't have any data. Your logged in state has like the username or a token in practice, and the error state just has a message. And in the UI, it forces you to always check, hey, what state am I in, and then render the appropriate child widgets. Okay, now one thing that is very specific to our implementation with these asynchronous jobs and updaters, which I didn't want to like hide, even though it's like a little bit complex, but so you can make up your mind how you like it. So sometimes what might happen is that you, with triggering a block, you immediately do something else in your UI. Maybe you need to update some widget or disable some button like immediately, and then it would be really, really handy to know, okay, when is this block actually done? So that you then can set your UI back into the like available state or whatever. And just making that based on the state and like checking the state transitions yourself is a little bit cumbersome, that you say, okay, it was loading before, now it's not loading anymore, so now I should update myself. So this is why here is like a small pattern how you would actually return some value. In this simple case, it's just, okay, when is this method actually done? So basically, you return a future by means of this completer function, which is standard in Dart. And at the last step of your updater job, you just say, okay, now I'm done. And you could also have like a return value here, or whatever makes sense. This is something that is important, so we wanted to show it, but it's something, it's also so rare. I think we found like 3 places in our code base that we didn't build it into the framework proper, but it might be that for other use cases, it comes up more often. And then over there, on the right side from you, you would see, okay, when we do the start login from the UI side, we would immediately say like logging in progress to disable the button. Then we do our block operation, and afterwards, once we have awaited it, we enable the UI again. So this, like, if you're strictly coming from the Redux side, this might seem like a little bit in contrast, because now you have 2 places where you have like the state. You have a little bit of state in the UI and the rest of the state in the block. For us, that is really rarely used, just to keep things manageable. But yeah, you don't have this one huge source of data, of truth for everything. But yeah, you have it a little bit distinct there, which in those cases is fine, because nobody needs to query that UI state. Okay, so recap for the whole state queue class that we just rushed through. So for us, the biggest simplification is that there's really only one updating job in progress. And since that can be async, it is just async by default. So far, we've been fine with just having that. If you had like a lot of more UI-driven state without any API calls, it might make sense just to keep to a simpler like value notifier approach. So you can update everything synchronously, makes the whole waiting game obsolete. So that might be really, really nice for those cases. Yeah, just fit, or just use whatever fits your needs. This is like for us and for API, but it might not be applicable to everything. So one thing we didn't yet get into, but is like a little bit implicit for us because it's just how the app evolved, is, I mean, with this approach, you could build one huge block for all of your application, But actually what we do is we build tiny blocks all over our applications only to solve like the problem like immediately at hand. So usually that's cool because the states are like independent, like some special slider recommendation widget doesn't need to know about your login states, so we keep them separate. And only very rarely do you actually need to connect them. And to make this many-fold decentralized states like really easy, we created another widget that Henri is now going to talk about. Good. Okay, we just speak even faster.
Okay, so we have 4 minutes left. So this like kind of with block utility, because we have so many like local blocks, like we can have, I think on one page we have like 10 of these blocks rendered or like created at the same time. We didn't want to repeat ourselves for like creating them, removing them when necessary. So we did, we followed the Flutter pattern of everything is a widget, and we created a so-called with block widget. As you can see, it gets like, we have a very basic counter block, and on the left you can see in the build method down there, there's a create block method that just returns an instance of this block, so we call. Inputs, we're gonna just like skip it for now, and then our builder method, and that's more or less where you return then your like actual tree of widgets that depend on that value. So what it gets, it's like a build context. We don't need to get further into it. The block itself, so the instance, so you can see that we can call methods on it and change some state, for example, through that. And then our state or our value of the block. And whenever that block updates, we will recall this method, the builder method, and then our UI will reflect the new state. This is very nice because like our blocks are very specific to their use case and really only handle the data and the methods that they actually need to do. It gets easy like to like then like think about it and fix problems because you don't need to think about like the whole application state and like can work in a very small scope. Yeah. Quickly, what's not in our blocks, as Timm said, for example, animation states, scroll positions, we usually keep out of it just because we don't feel there's a need, and polluting other blocks with that kind of data seems unnecessary to us. And we also keep our full navigation stacks outside as it's managed by Flutter. So syncing them would be an issue again. We will quickly talk about app-scale state management now. Yes.
Yeah, so now we dove like really deep into the code of just this one class and how it might help you and how it helped us. But of course, we now need to combine all these building blocks to build like a full app. So with this with block widget that we saw, it's very easy to create like lots of blocks for very specific use cases to only encapsulate like that small part of the business logic. And here we have like a screen from our product listing page. And in the bubbles, I actually marked some of the blocks that we have available there. So you can see that the title and also the second line with the subcategories is derived from the block number 1, which is like the primary one. And then there's 2, 3, 4, and 5, which each handle like a specific edge case in their own block, in their own scope. So in here, what you can't really see in the UI or by the numbering I chose is that there is like a tiny bit of hierarchy. So the one block holds the data, what is the current category and what are the current filters. And that is then just through the widget tree descended down to all the other widgets. So if you would draw them, like 1 would be on top and 2 to 5 would be dependent on them, just so that we always only have like one authoritative state for any piece of data. This is definitely not something that we would want to lose by going like decentralized. What can happen, of course, now that we have so many widgets that all have the same input state, that they make the same API calls. And this is why, on top of the basic HTTP methods provided by Flutter, we added HTTP caching so that there is no like performance or user impact on having this decentralized code structure. It shouldn't take longer to get the data on screen or cost you more of your bandwidth. Next, one thing that also comes up is like have a tiny bit of GlobusState, which I'm going to rush through, but it's really cool, especially if you're new to Flutter. Look this up. It's nothing we have built. It's already there, a very popular library called Provider. And basically, our blocks, or also like all other value notifiers, you can just make available at some very high point in your widget hierarchy, and then query it further down. And if you have like a block like this or a normal value notifier that updates whenever its main data changes, just using it like here inside your build method will automatically call that build method to be recomputed whenever your state changes. So that makes it like super easy and foolproof to use states. And yeah, this way we don't have to like pass it down all the layers. It's just available. We use this for like global stuff, like your user login state, your basket, etc. Next thing, very quickly, also cool, can't dive into it here much further, is for testing and this asynchronous operations. You always have the problem, okay, when do I run my asserts? When am I done? Because if you're familiar with Flutter test, you would just say, okay, render me this UI, but what you actually want to know is when the blocks behind that UI are done doing their stuff. Which the UI can't tell you unless you like assert, hey, is there a loading spinner on screen? If there is, I recheck like in a second. So to make that more convenient and actually know when like the blocks are done, we added this helper that runs all the tasks to completion. And that way we just wait until our blocks are done, and then we know, okay, now the UI must be in the state reflecting whatever is the current state, and we can assert on that, like we do here, that the data has actually been loaded, and then we check like that the text is on screen, etc.
Yeah, I'm gonna quickly go through something we call app restart, and that's a choice that we made really early in development. We ended up having like multiple countries, a potential user state, and so on. And these would all affect kind of each block in some way. So whenever your country would change, you would need to update all of the blocks. What would you do with all of the data that is in there? Depends on the block. You would need to think about all of that stuff. So we said, okay, let's not update our blocks. Let's say whenever the country changes, we're just going to re-render our complete widget tree. This causes like all of the blocks to be removed and then recreated. This makes like thinking about what might actually change very easy, because you have to handle one less case of some dependencies being updated. If you're familiar or like used React before, you know there's like a key property, and it also exists in Flutter. So we set in this in the middle of the code, we set like key on this like builder widget, and we give it a kind of like stringified version of our config state. So whenever this string changes, Flutter will kind of discard our whole widget tree and recreate it from scratch, and including our blocks and all of our data. So we need to refetch it again. Just something we made like very early in development, and what you don't see is like that you lose all of the UI and like navigation, especially navigation state. So you really end up with like a completely new kind of app restart when the user would normally open the app. But it makes like thinking about and having to deal not to deal with these issues very like easy and comfortable, to be honest. So yeah. Yeah,
so the point there is just to not handle this like it's not even once in a lifetime events of your app, because usually that never changes. But if it did change, you would have to either support it in all of your states. Okay, now that changes, so clear everything that is like not needed anymore, or for example, clear user data when the user logs out, and we just throw everything away and rebuild it. With Flutter, that's super fast. Yeah, there's just very rare a case. Okay, now it makes sense to go back to the previous UI or something. Yeah, so the underlying principle is probably there. Okay, don't try to solve problems that you don't have to have. Okay, yeah. Now we are already like 5 minutes into Q&A time. Really, here's just a quick recap of all the topics we covered. There's a link to the code, and there's packages on PubDev if you want to check it out. Have some suggestions to it. Would be super interesting to hear if like anybody is really happy with having like a stream-based block approach in their Flutter application. If that works really well for anybody, I guess we could learn from you guys. So, yeah. Bring the questions.
Is it?
Yeah, the guy over there, blue shirt. Yeah, okay.
I have been experienced some problems using states handling with blocks because I had some nested callbacks, as you all know the hell, which kind of ruined the states along the way. So I would like to hear more from you how you handle certain situations where you have the state queue, but you have some events flying in.
What do you mean flying in? Like?
I mean, when you have something
Like a search, for example. Like.
Yeah.
We usually then tend to also like use custom stream APIs and not our own state queue, because it's just not built for this. You would want to have like, okay, I want to make this API request, but at the same time, the input field value should still be changeable, right? Like that's just not possible with the state queue, what we introduced. So we usually just do then bare bones streams as well. But we do tend to have like kind of, okay, we have methods on the outside and this single state on the outside. Internally, it just then uses streams.
Yeah. Yeah, so the primary point here is that it's not interruptible, but for search or typing, you would want to interrupt it. So that's definitely something it's not built for. With regards to doing that, we also, because we want some very special behavior which is not easily buildable with like streams, so we build our own classes, but yeah, it's basically a custom-made block, which is cool. Everything is just a value notifier, so just bring your own for your specific use case. Yeah?
I would be interested, why did you switch from React Native to Flutter?
Good question. That would be a separate talk all by itself. Like
it's mostly speed and development experience, which we had issues with both in React Native.
We can like talk about it afterwards. There was also like a meetup at About You like 2 months back or something, exactly concerning with that topic. So I can link you the slides if you want to. Yeah, it was basically a combination of like some basic issues plus our current implementation, and yeah, that we wanted to have this fresh approach.
So is your app now completely migrated to Flutter already, or is it now running with native?
At the moment, the app that's currently live in the App Store is still React Native. We're about 3% probably like away to like launching it. So just fixing the last few bugs.
In Belgium, so you have to go to Belgium to get it, but it will be there. No, but the idea is, okay, we make like a complete transition. Yeah. Like, because there's just baseline framework overheads, that if we had both frameworks in one app, it would just be like huge. Yeah.
You mentioned you're doing that for performance reasons. One of the reasons is performance. How much performance? How much did you improve in terms of performance with Flutter compared to what you had with React Native?
I would say we never had like these performance issues that we had before, like for some custom UI or custom animations. It was just always super fast. Nice. And one thing, I think it was like a side note on some of the slides, like even all the animations, you can drive them with such states. And yeah, it's like still super fast, and that is like really, really impressive. You don't have to change the model. Like if you would do it in web development, you say, oh no, I have to do this animation in CSS now. I have to break out from my JavaScript code. But yeah, like UI performance-wise, we never had any issues there. And
yeah, I guess the biggest like measurement that we could see is like app startup time. Flutter just really being fast on also older Android devices where we definitely had issues with React Native, and that has definitely improved. Yeah. More questions?
yeah.
With your async approach, did you gain performance then, or do you have issues with unresponsive UI when you're waiting for more async calls to finish before updating the state and rendering?
No, so I think the biggest thing we gained was just like clarity, and okay, we know what's going on, and we prevent like different things at the same time, messing with the same data, and then not knowing exactly, okay, where did it come from? I mean, in the Redux DevTools, you see what happened, but you don't see like exactly where it came from. But yeah, as you said, one of the problems, depending on the use case, would be that now your UI might be blocked. So usually we show the spinner, so if you add something to the basket, you have the spinner on the button, so you don't press twice because you're on a slow network or something. But yeah, can you think of like a situation where you would want to keep the UI responsive? I mean, yeah, text input is one. Like yeah, usually we just have this very few primary operations, and they just like block the UI anyway. For some screen gets loaded, and otherwise, since the blocks are so small, they wouldn't like prevent much UI from working, right? It's just always like tiny stuff. But yeah, that's probably the most important design there. That you need to have small blocks, otherwise you can't have some background operation blocking your UI or something. That wouldn't make any sense here.
Could you achieve the same state management just using provider?
No,
no. Provider is more like dependency injection, basically, so that you can declare kind of for people with React background, React context would be like the same approach.
So yeah, I mean, provider is like a great library to make any object or any instance available in your whole render widget tree, but you still have to put something into provider. So I think in the simplest example, you would just put in like a value notifier, just like a placeholder class where you can write any value. And this is like an alternative that you can put into your provider to get this automatic re-rendered by the Flutter framework and to have this automatic inheritance, so your data is always available. But they always work together. So sometimes we hear that or we read that in some blog posts that they do state management with provider, and that's just not what it does. So it's always this combination of provider and whatever you put into the provider. Okay, thanks.